Welcome. So we're going to talk about binomial distribution. So we sort of talked about generally what's a probability distribution. Then we went down to discrete probability distributions and talked about expectation. And now we're looking at a specific type of discrete distribution, and it's called the binomial distribution. We've talked about it a little bit before from last year. You should have some concept of what it is. But essentially a binomial distribution is a probability distribution that you're trying to do something a bunch of times. You're doing a bunch of trials, and the trial either is success or failure. You don't have any other option. So either this thing happens or it doesn't. All right, and if that's the case, then it's called binomial because there's just two outcomes. It either happens or it doesn't. And what we do is we define the probability of success as P, and we define then the probability of failure as Q, because it's the next letter in the alphabet, I guess. And so we say P is the probability that something happens, the success, and sometimes that definition of success is different, and it doesn't necessarily mean success. It's just success in the sense of that thing happening, whatever we're measuring. So sometimes you'll see experiments about do you get a cold? Well, you wouldn't call being successful getting the cold necessarily, but it is success in our trial because it's the thing that we want to have happen or we want to know about. All right. So you have in a binomial distribution, you need to know two things. You need to know the number of trials and you need to know the probability of success for each trial. All right. So here's an example. Suppose that you have this spinner and it has three blue edges and one white edge. So there's two possibilities. You either get blue when you spin it or you get red. The probability of getting blue, that's what we're going to define as success. So if we define that as success, then that means the probability of our success is 3/4 because the chance of getting blue is 3/4. And the probability of failure then is 1/4. So if you think about swirling the spinner 3 times, we're going to just spin it, write down what our possibility is, or probability is for that 1 spin, 2 spin, or 3 spins. You basically have 4 options for how many blues you can end up on. You can either end up with no blue, which means you got white every time. You can end up with 1 blue, 2 blue, or 3 blue. If we want to figure out what those probabilities are, we look at this and we just look at if it's no blue, then they're all white. The probability of getting white is 1/4, so it's 1/4 times 1/4 times 1/4, so it's 1/4 cubed. If one is blue, then it's either blue, white, 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 blue, white, or white, white, blue. In each case, each of those branches, if you kind of just look at the first one, there's blue, white, white, and it's 3/4 by 1/4 by 1/4. So there's 3 of those possibilities, but they all have the same probability. So we write 3/4 times 1/4 squared, right? Because the white is 1/4 times 3. To get 2 blue and 1 white, you can go blue, blue, white. You can go blue, white, blue, or you can go white, blue, blue. And again, each of them have the same probability. Each branch is 1/4, 3/4, and 3/4 in some combination. So 3/4, 3/4, and then 1/4, 3/4, 1/4, and then 3/4, or 1/4, then 3/4, and 3/4. But if you multiply them all together, it's always 3/4 squared times 1/4. And there are 3 of those. And then the probability to get all 3 blue is just 3/4 cubed. And you'll notice, if you remember your binomial distribution from last year and the concept of Pascal's triangle, that these numbers, if you just put these in here, they're not written there because they don't really matter to our calculation. But you see how you have 1, 3, 3, 1? And it should remind you of x plus y cubed, because you start out with 1/4 is cubed, then it's squared, then it's 1, and then it's none. And 3/4 starts out at 0, then it's 1, then it's 2, and then it's 3. So you're really doing x plus y cubed, except it's actually p plus q cubed. All right? And so that's why it's called binomial, because it follows the binomial distribution. Okay? So you can kind of write it out as a formula. using the binomial distribution equation that we used last year. So you get the probability that x is equal to r is the combination, n choose r, p r, q, n minus r, where p is the probability of success, q is the probability of failure, n is the number of trials, r is the number that you want to know about. All right, so if I want to know what's the probability that r is 1 or 2 or 3, that's what gets plugged in there. All right, now you don't have to know how to use the formula necessarily, because we're going to do all the calculations on the calculator, and I'll show you how to do that. But you do have to understand what is going on. It's really just an expansion of p plus q to whatever power. All right, so it's binomial because of that. So if we look at an example, here's an example. It says 72% of union members are in favor of a certain change in their conditions of employment. And we're going to pick a sample of 5 members. And I want to know what the probability is that 3 members are in favor of the change in conditions, and then at least 3 members are in favor of the change in conditions. So when you're looking at a binomial distribution, we said you need 2 things. You need the probability of success. We just have that here. Okay, the probability of success is 72%. And then you need how many members in this case, but how many times or trials you're having. So it's 5. So we write down n is 5. Our possibilities in terms of being in favor, you could have nobody in favor, 1, 2, 3, 4, 5 people in favor, and the probability of success is our 72%. So the first thing we're looking for is the probability that x is equal to 3. To do that, what we do is we just go to our calculator, go to your scratch pad. It'll let me, there we go. Oh, I want to be on the calculator, and I'm just going to go to menu, and then statistics, and then distributions. And there's a whole bunch of them in here, but there's 2 in particular for binomial. There's a PDF and there's a CDF. This is a point distribution function. That's what the P stands for. So if you're looking for a probability that x is equal to a specific number, you use that. If you want the probability that x is bigger than a certain number or less than a certain number, you use CDF, because this C stands for cumulative distribution function. So we want the probability that x equals 3, so we're going to hit this. A binomial PDF. The number of trials is 5. The probability of success is 0.72. And the x value is 3. All right? And we hit OK. And that's our answer. So the probability that 3 out of the 5 members are in favor is that number. Okay? And if we jump back to our notebook file, you'll see that. You don't have to, by hand, plug the numbers in. You just have to know how to do it on the calculator. The second one says, what's the probability that x is greater than or equal to 3? So that is a range. So you have 2 options. You can find the probability, well, you actually have 3, I guess. You can find the probability of each of the things occurring. So you can plug in what's the probability that x equals 4, 5, and then add them together. So 3, 4, and 5 added together will give you your answer. Or you can do 1 minus the probability that x is less than 2 and just find the probability that x is 0, 1, or 2. Or the easiest way to do it is this lovely calculator allows you to go into your statistics and your distributions and choose a binomial CDF. And all it asks you is the number of trials. So we say 5. The probability of success is still 0.72. The lower bound is 3 because it's greater than or equal to 3. And the upper bound is as high as you can go. So we can go up to 5. We just hit OK. And there's our answer. It's 0.862352. We can round that off to 0.862. And that's our answer. Okay? So for binomial distributions, you just have to know how to use the calculator to find probabilities, but you have to understand when it applies. It applies to discrete probability distribution functions. They have to be discrete. There has to only be 2 outcomes, and then the trials have to be independent. And you know what that means for probability last year. They can't affect the probability of success in one is not affected by the probability of success in the other. All right, so the probability of success has to be the same for each of the trials. They have to be independent. And that's how you do binomial distribution.